This is the second video on the National 5 Maths topic of circle geometry. In this video we're going to look at angles formed by triangles inside semicircles. Here I've got 5 circles with their diameters drawn on. So each of these has got their diameter drawn on, like so. Essentially what I've done is I've cut each of these circles in half. Okay. What I want you guys to do is I want you, if you have a protractor, to try measuring the 3 angles and writing them down on the diagrams. Measuring these, trying to be as accurate as we can. You should see I've got 90, 80 and 10 degrees on this triangle. Here, second triangle, I've got 61, 90 and 29 degrees. Third triangle, 45. I've got 45 up the top there and 90 degrees there. The last two, 13, 77, 90, and the final one, 37, 53, and 90. Notice here I said, what do you notice? Well, hopefully you've noticed that in every triangle, I've got 90 degrees. Now, obviously, depends how accurate your measuring's been, but whenever we've got a semicircle and any 2 chords drawn on to form a triangle, remember a chord is a line that passes from one point to the other, so that's a chord there, it doesn't pass through the center. Whenever we've got 2 chords and a diameter, we've formed a right angle triangle. A triangle formed inside a semicircle is always right angled. And it's always right angled at this point of contact here, not on the diameter. There's quite a good video here, a little video proof that there's a little bit of algebra to prove that. It's a, I think, 2.5-minute video. You can type in that URL or I will try and link it in the comments, but that's worth a watch. So, lots of angle problems can be done with this. Identifying missing angles. There's also Pythagoras trigonometry can be used, which we'll see in a later video. Here, these 2 triangles. I've got the line AOB, so passing through the centre O, so I've got a semicircle. So that means straight away I can identify X. That's 90 degrees. As soon as I know X, which is 90 degrees, well, I can find angle Y. Angles in a triangle all add up to 180 degrees. So I can do 180, take away the total of these 2 angles, which would leave me with 22. Second one, again, BOC, passing through the centre from one side to the other. So that's a diameter. I've got a semicircle there. So this means straight away I can identify X as a right angle. Again, Y, the third angle in a triangle. So using these 2, I know they'll add up to 180. So Y is going to be 180, take away 90 plus 27. So that should give me 63. Bottom 2, slightly tricky, well, slightly trickier. I've got, on this one on the left-hand side of the screen, AOC, passing through the centre, diameter. So, I've got a semicircle, so straight away, X, I can identify that as a right angle. Now, I've got 2 angles here with letters. I've got Y and I've got Z, but I've got no other information about my angles? Well, apart from the fact that these are equal, how do I know they're equal? Well, I've got this pair of dashes here on that side, and I've got that pair of dashes there. This is telling me AB and BC are equal. I've got an isosceles triangle. So, y, I've decided to find this angle here first, is going to be 180, take away 90, take away the angle I know already, and then it's going to be equally shared between the two of them. I've got 180 take away 90, then I'm going to split it between the two angles there. So 90 divided by 2 is 45. If I know y is 45, z has to be 45 as well, because it's an isosceles triangle. Now, this one, a little bit trickier. I've got two triangles. I've got the triangle OAC, and I've got the triangle OCB. I suppose there's a third triangle there as well, ABC. That's the interesting one, because, well, through the centre, so that's a diameter, I've got a semicircle, so it means up here I've got a right angle. Now, I'm going to mark that in, but notice I've not actually been asked to state that, but that's going to come into play later. Again, just notice these two lines and this triangle here. I've got the two dashes, I've got an isosceles triangle again. So that means these two angles are the same size. So that means the angle U has to be 42 degrees. I can find the angle V because I know the two angles already. I know both of the angles here are 42 degrees. So I can take away the total from 180. So 180 take away two lots of 42 would give me 96. If you've got a drawing of a decent size, which you will have on an exam or assessment paper, you could be writing in on your diagram as you go. Looking at this now, I've got two I can find. I've got a route for finding x or w. Looking at w, again, the fact that this is through the centre, I've got a diameter here. Straight line, the angles in a straight line add up to 180. So taking the 96 away from 180 will tell me what this angle here is. It gives me an answer of 84 degrees. Again, more dashes. I know this is the same as this. Again, notice it's two radii there. So I've got another isosceles triangle. So this means this angle is the same as this angle. Diagram's getting a bit cluttered, so I'm going to remove those. Well, I don't know how to find y, but if I look at x up here, my right angle has finally come into play. I know that this side here is 42 degrees, so I just need to figure what takes me up to 90. 90 degrees, take away my 42, well that's going to give me 48 degrees in here. Because y is part of an isosceles triangle, y is going to have the same value as x. He's going to be 48 degrees as well. This is only one way you can solve this. There's a couple of ways you can solve these types of problems. This was a nice example. This example is angle y. If I look at the whole triangle, I know that's 42. I know that's 90. So y could have been one of the very first ones I found. That would have then led to x, which would have then led to u, which would have led to v, which would have led to w. Lots of ways I could have done that. This slide is marked task, notice. So this is a task you guys can be doing. So you can either have a crack at some of these just now, or these will be ones we look at in class. Worth noting on this one here, you may be tempted to think that this is a symmetrical diagram, but you're not really able to make that assumption. But nothing that says that, okay? So be very careful with that one.